Hello everyone, my name is Akriti Dhyani and today we are here for a webinar on Industry 4.0. We have with us Mr. Shashank Singh, who is the creative head of Yeppar. Hello Shashank.
Thank you for having me.
So, my first question would be for you, what is Industry 4.0?
4.0. So, first of all, it's not 4.0, it's 4.0. So, there have been a lot of industrial revolutions like Industry 4.0. So, they have been about creating a lot of commodities, products with efficiency and better yield and better quality of yield as well. So, the entire idea of having an industrial revolution is adding technologies into making stuff, making it more efficient, making it more quickly, and creating profits along the way. So when we have a lot of technologies like big data, like AI, like blockchains, so having all that package, helping you to create better quality and faster quality of products, that would be industrial revolutions. So even training would be even a part of industrial 4.0, where you're actually creating a better human resource who is able to actually create a better output. So that's through trainings through virtual simulations. Simulations as in augmented reality and virtual reality. With those technologies coming in to train people, so that would be one place where you are creating a better person, better employee who is able to deal with a lot of pressures in manufacturing areas.
Could you please tell me or could you name some of the technologies that come under Industry 4.0?
Okay, so AI would be the biggest one since it is actually taking out a lot of pain points in the manufacturing. You need to have a better decision for the person to take, so AI will actually calculate which is a better opportunity to actually invest in, and with that you can actually see to it. So would be the one thing. And AI would also actually go for the big data. So that would be one place where you actually have a big data and you're churning that big data to have a better result. So big data is another thing. Then blockchain, where you're actually identifying, you're actually keeping account of all those things that are activities which are going on, or the inventory. So you are managing inventory through blockchains as well, and the entire life cycle of production that can be handled by the blockchain as well itself. And then you have the employees who are being trained by the AR and VR technology, so they are a better person to deal with the environment. So even that's another technology to be used in. We as in Yeppar, we have been fortunate enough to actually help in this industry 4.0 through training a lot of people and giving remote assistance as well. Remote assistance, as in you can actually treat somebody who is not much aware of the technology or the machine they are operating on, but the expert from a remote area can actually give the assistance to that person through the immersive technologies like AR, like HoloLens device which Microsoft creates. We create software for it. So we create that remote assistance feature for them.
Okay, that was great. So, my next question for you would be, was there other Industry 3.0 or and Industry 2.0 before, like Industry 4.0?
Obviously. So since we are at 4.0, that means we have industry revolution before. So it started with like 1.0. So that 1.0 was basically having steam and water. So machines were actually powered by steam and water. So that was one industry revolution. What exactly are these industry revolutions? Is basically if there is a major shift or major transition or change coming into how we create stuff, is the industrial revolution. So first, we had the steam engine. We have the power of steam to actually make the things move. So with these machines moving with steam and water, that was the first industrial revolution. That was long back in like in 1789, 1784, something like that. And then we came to the in 18th, basically we have the second revolution, which was I think mainly about conveyor belt system, where we actually have the mechanized system to move the trolleys, so you can ship your product from one place to other place. Then we have electricity as well to power those things. And in the third revolution, is the major one, we had the computer. So computer was the biggest thing that came into this manufacturing area, because you have automation over there. You have something to actually think and take decisions, which was a computer. It was able to manage stuff over there. It could actually see you have the data over there. You can actually have that into your computer. So computer was the biggest thing that came into the third revolution. Now we have Industry 4.0, which it's not 4.0 as in, it's 4 basically, but we call it 4.0 because it's major part of the digitalization.
Okay. So, my next question for you would be, how does Industry 4.0 help in lowering operating costs for businesses?
Right. So when you're operating a business, you have a lot of areas where you actually so there are many invisible things that go about in the entire business. So when we actually incorporate things from technologies from the industry 4.0, so they bring in about these insights, these analytics, which you can actually sit down and actually think about that way to actually see to it. Then you have the decision making things like AI to actually compensate for your inability to see those data, those analytics. So it will actually tell you that okay, this thing is wrong actually. So if you feed some data to it, it will actually give you an output, a desired output basically. So when we talk about Industry 4.0, it's addressing to most of your areas where you're actually bleeding. So that's how you're actually working about the operating cost because you are finding the pain points through these technologies like AI, like data, and all of those things.
Okay. So, my next question would be, how does Industry 4.0 improve product quality?
Right. So, what actually creates a product? So, product is anything that has some utility. So, when you actually able to create a better utility by designing a better product, so it will create result into a better product, right? So, when we talk about these Industry 4.0, all the technology it brings in, so it is actually able to create areas where you can actually improve upon. That means that if you have automobiles, so you are able to have a better simulation of what your car should actually behave and how it should look. So automobiles is all about having the best performance and have the luxury as well. So if you can actually create those simulations where you can actually test out those scenarios, so when that comes into industry 4.0 as well, that means that the basic weight of the person, how he actually sits on the chair. So even that comes into luxury, and that comes into the ergonomics as well. So you can actually lean into those, you can weigh those things in this environment, in a simulation, and you can work about it. So you can create a better product, I think, a better car for the uh, people to actually enjoy.
So, how does these technology change the cost? Because you're improving the product quality
Right, right.
using the technology. So, is it cost effective or is it a heavy on a pocket?
So when you're actually designing a better product through the simulation things, you can also look at the material. That's a good question basically because I skipped that part. So the entire idea is that you're creating a better product, right? What material do you actually require to create that thing? So when you have the simulation running, you can actually look at the materials aspect as well. Like you have to use a very sturdy material for it, or you have to use something of a lighter material or a rubber like thing can actually work. So you can decide on that as well. So you're right. So you're cutting the expenses of creating a wasteful product by actually having a simulation running over there instead of actually creating an actual thing. So that's the one area you actually lowering your cost through failing faster. That means that you are failing at in a virtual area, a harmless area, but you're not actually.
Basically, we are failing at something we haven't created, but it's just the idea of creating. We have not
Right.
created the thing, but we are the idea. We just visualize something, and when we visualize something, we before creating it, we just get to know ki, is it going to be a waste
Yes.
or is it going to be useful?
You're totally correct. So basically, yes, so we are actually doing that by simulating. You're actually creating. So it's on paper, it's in the virtual system. So even it gets wasted, it's okay. So we're actually reiterating over there in a simulation only. But when we will come into actual production, we will be able to actually have a better workplace layout to actually have an efficient system of creating those things, and we can actually decide upon where to actually invest in, as in materials, as in the machines as well. What needs to be created for these things through a simulation.
Okay. How does Industry 4.0 help you manage and optimize all aspects of your manufacturing processes?
So again, since manufacturing is a big and heavy industry, you're actually dealing with a lot of raw materials. You're dealing with a lot of products which you actually can see and cannot see. So there are a lot of variables which are acting upon the manufacturing or the industrial processes. Um, since there are so many elements which are come into playing, so we have to take very a granular approach to actually see to where these things are. So having analytics, proper inventory, proper seeing the entire process as a whole is the biggest thing that you can achieve over here. So that is where the Industry 4.0 comes into play. It sees the entire process as a whole, so you can actually manage it properly and can efficiently deploy resources. Okay.
What is the major drawbacks you face in this process?
Again, that's where I was actually going to go about. Is that pain points is one thing, because there are a lot of invisible things which are happening. There are a lot of areas where the employees are actually not able to find a proper place. Actually, cannot get the work done because they're not aware of the things that they're working on, and they are not able to deploy all of these skills to that particular thing because they might not be good or efficient for that system. So that is one thing where we in Yeppar have actually faced, because there are a lot of companies who have a lot of human resource, but they are not actually able to put their entire skills 100 with the 100% outcome. That is because they might not know about the system they are working with, or something that they are not actually trained for. So they might have the skills, but they might not actually have a good knowledge about that thing, or they are not in a proper layout of the space. For example, if there are four people and they're just passing a ball, okay, suddenly somebody passes a carton, so that's a different object that you grab onto, right? So they, since they don't know how to hold it, that creates a delay in the time. So identifying that thing is actually a crucial thing, right? So Industry 4.0 actually finds a good engineering solutions to actually solution for these problems, where you actually have the entire process laid out in front of you, and you have a digital overlay systems for actually how these things are going. You have overview of these things, and you're actually categorizing it and creating sectors for it. So that way you know where the resources are going, where the resources converting to different is transiting to a different form, and then how the services are being laid out to the customers as well.
Great. How it gives you access to the real time data and insights you need to make smarter and faster decisions about your business.
Faster decision is a good point, because when you have all this data, you need something to actually give you the insight as well, that which data is important, which is into more priority. So that is actually facilitating this faster decision making, because when you have this data in front of you, you're not overwhelmed with the data. What is happening is basically that you have a data and you have the prioritized data as well. So since everything is categorized, you know where to look and when to look. So you can actually compensate for your time as well, like what to see first and what to execute first. And since these opportunities, this AI and all of these things are giving you the opportunity to actually see the data, visualize it in form of AR and VR, and then you can actually make a fast decision whether if this thing is good, it's good for approval or not. So this is the way you can actually counterbalance, you can compare, and you can actually find out better route as well, decide a better route as well.
So, since there's a lot of data and the amount of data is pretty huge,
Yes.
so do you face any loss of data during this process?
Loss of data is not
And
an
also
issue.
how you deal with it? How to, prevent the loss of data?
Lost data could be only in case of a hazard, but even that's being taken care of by the AI or the managing systems as well, which are applied in the Industry 4.0. But so they are basically actually managing whether you have sufficient space or sufficient areas where you can prevent hazards, so that you don't lose some data, or you have some cybersecurity rules which actually make sure that you have a proper system which will not any leak any data, or actually not have the data exposed somewhere. So that might not be the issue.
Okay. So, with that being said, I'll move on to my next question.
Sure.
When we talk about the technology providing a near real time bridge between the physical and digital worlds, what is digital twin in Industry 4.0? So, I have been hearing about this digital twin a lot
Right.
lately, but I do not know anything about it. So I would love to hear it from you.
Okay. So, again, so we're talking about the real machine and a digitized version. So even in pandemic, we know that we are reliant on technologies. Technology is our basic need basically today. So what is technology today? It's basically digitization. We are digitizing everything. Everything that's on paper is being converted into zeros and ones, right? So the entire idea about digitizing is you can store that data in infinite possible ways. You can have everything converted into digitized. That means you can manage the space. You can have it readily available to you because it's digitized. It's a virtual thing. So when we talk about digitization or digital twin, basically, we are creating a digital twin, a virtual twin of an existing machinery. So if you have a vehicle, right? So you have a digital twin of that vehicle or a car on your mobile phone. So you can see whether what's the fuel percentage, what's the air in the tires. So it's a digital twin of that car basically. So you can see that car visually in an AR space or in a virtual reality, but it's a virtual copy of an existing machinery or machinery as in car for this example. So you have a car. The maintenance date for the car is reflected on the 3D model of the car. So that's the digital twin. That means that you have actual machinery, a physical machinery, and it's connected to the a server. It's sending all its input to the server, and that server is being updating and keeping a record of the what's the status of the car. Um, when it was the last time it went for the maintenance, what's the fuel percentage in the car. So it's keeping a track of that. So that copy is in your mobile phone or is in your immersive systems. So you can see that thing over there. So that's a digital twin. That you have a real object and the a copy, a virtual copy, a digital copy of it in your system, basically.
Okay, great. How digital twin enables you to remotely monitor and control equipment and systems.
Right. So as we discussed, digital twin would be the counterpart for the actual physical object, actual physical machinery, actual physical product as well. So when we have these sensors that are present in the machinery, they give the information about the its status basically, whether that machinery is active, is inactive, or does it require some kind of any fuel, any product that it requires. So it's maintenance as well. So all of those data are sensor controlled. So those sensors actually give the output to the server. So that server actually acknowledges and actually keeps a steady eye on the machinery, and that thing is actually bounced back to your systems, which actually control the which actually takes the entire process as a whole, as we had discussed earlier. That the entire idea is to see the entire process as a whole, so that you can manage it properly. You can find more faster approaches to actually find the leaks and everything, which actually are the pain points. So that system is actually taking those sensor data to the cloud. So that is how the digital twin actually works. So you have the one entity which is actually taking all the data and taking the right data. Then you have one entity which actually facilitates the data transfer, and the other entity is basically the AI, or it's the data which actually takes all the data, categorizes it, and actually gives it to the right person, or whenever you require the data, it gives that data. So these three components actually work in the digital twin. Then I can sorry. So it can actually facilitate the viewing of that digital twin through immersive systems as well. So as in so Yeppar has a global clients as well. So these clients actually require that machinery, the digital twin of that machinery, to be viewed in their remote areas as well. So you have machinery in Hyderabad, then you have one machinery in the Saudi Arabia. You want that person to actually see both those machinery in his virtual space. So you can do that because you have digital twin of those two machinery across the world. So one is in India, one is in Saudi Arabia. You can see the data of those two machinery in this space, either he is in Germany or wherever he is. So that's the possibility there.
So is metaverse and digital twin the same thing?
Metaverse would be the a different way to actually visualize, interact with internet. and also socialize. So that is the metaverse. It would be more of the metaverse would be a total digital universe. So whatever you have in the universe, you can digitize it. So that would be the metaverse. It's a digital universe basically. You There are a lot of potential over there. That is, you can have those machinery which we talked about, the digital twins, in the metaverse itself. So with the tools of metaverse, you can actually program and code for these machineries data to be streamed to this particular instance or the particular 3D model, which will actually show the readings of that actual counterpart, the real physical counterpart to it. So they are the same thing, but a metaverse can actually have these capabilities to show the digital twin of some machinery, an actual physical thing. You can show that in a metaverse, but metaverse and digital twin are not the same thing. Metaverse can actually show the digital twin of a washing machine, a digital twin of a machinery, but it's a total different thing.
So you mean metaverse is basically a virtual environment, and digital twin is an entity.
No. So metaverse would be the entire world. But it's digitized. Metaverse would be the internet. Whatever internet can give to you, that would be inside it. But it has a virtual feel for you. It's a second life in virtual. It's a digital life. So whatever you can do in the virtual world or in the real world, that can be that's the metaverse basically. But the digital twin is basically having a component which is a virtual thing and the actual physical thing. They both will be mirroring. The virtual thing will be mirroring the actual part. That will be digital twin.
Okay. So moving on to the next question.
Yes.
So is AR VR is only limited to train employees quickly?
Right. So augmented reality and virtual reality. These are technologies which are being incorporated into training, extensive training. So the reason they are incorporated into training is because these two are immersive mediums. That is, you can actually see the actual size, one-to-one ratio of an actual machinery. So the person who will actually work on that machinery will not be overrun with the machinery. That is, if I tell you to fly a airplane, okay, so at first you would not enjoy the idea that you will be flying a plane because there will be a lot of responsibility on you and you can crash the plane as well, right? So that's why you would not like to opt for the flying a plane right away. But if we give you a simulator where you will actually see how the cockpit looks, then you can actually see the functionality of the cockpit and how you have to be adjusted with those systems. So you have better mindset. You will be prepared mentally that okay, now you can play a role as a pilot to play to actually fly a plane. But then you will actually train for it. So that will be a tactile thing. Tactile, as in you can actually feel the controls, feel the buttons, and the position and the layout of the entire cockpit. So this way, you are actually having a muscle memory of how you are going to initiate sequences of how to fly a plane. But you will also see mentally prepared that okay, this is the size of the airplane cockpit and how you have to sit over here. So with this, you are mentally prepared, and you also know what are the sequences to land a plane, to take off. So you'll be more prepared, right? So that's why AR and VR are immersive. That is, you can actually feel that you are in that existing that space, or that airplane is existing around you as an AR. And for VR, you're actually inside a cockpit. So this way, you are better trained because your muscle memory is trained, and mentally you are actually prepared for it. So in these two manners, you're actually more ready to work in actual surroundings. So as per your question, you are saying that AR and VR are limited to basically training. So not limited, but these are the perfect tools to actually train somebody. But if you talk about more avenues where AR and VR can be used, is remote assistance. That is, suppose you are the expert and I am somebody on the field. I would not know something that I'm any problem that I'm presented with. I do not know how to handle this thing. I don't have the capability to understand what is in front of me. So I could wear a HoloLens or some other device. With that, you can actually direct me how to walk about, or you can give the information to me via PDF or any kind of textual data or any information through video as well, because you know what I'm looking at. So my first person view, my point of view will be streamed to you via laptop or your mobile phone as well. So remote assistance is one. Then AR and VR can actually help you see the whole picture. As in, if you are in a plant, you can see the entire plant through AR and VR mediums. So you have a better knowledge about the layout of the space. The term layout is very important because when you know the layout, you know where the things are will be shifting over the time of the life cycle of the product of the manufacturing process. So that way, you can actually have a better areas where you can focus on, because you have the holistic view of the entire place. That's why. So first one is the holistic approach. Is the second one. The first one would be the I forgot the first. Which was the first one?
The training one.
Training one was is the question. What was the first one? Decision making. So you can have a holistic view of the entire thing. That means you can actually see the whole thing, and you can actually see the areas where you can work upon, because you know the entire areas of that facility. That's why the layout is important.
So I've been willing to ask a question, but I didn't want to interrupt you.
Okay.
How effective is this AR VR in terms of technology, in terms of training, in terms of remote assistance, and in terms of you, as you're saying, ki the virtual walkthrough of a particular plant.
Right.
So how effective is the technology?
Efficiency comes in when it's more accepted, right? So if these technologies are accepted by the users, so they're more able to actually get a better output out of it. So acceptability is one thing. So to make these things acceptable is a very big challenge for us as a company. The reason is because these devices are not yet very easy to wear. Because if you're wearing a VR headset, it's basically you're not used to wearing a goggles, right? Every time you're not used to wearing spectacles, right? So even when these devices are still bulky in nature, even then we try to create a better experience for them, so that they instead of focusing on the discomfort, they actually go for the learning which they are getting through the AR and VR or immersive applications we are creating for them. So in terms of effectiveness, the application is one thing which has to be accepted by the users. The use of the application, the way they are actually expanding their knowledge through that learning process is by the muscle memory. That is, they're doing that thing in sequence, in proper sequence. They know how to evaluate themselves, because a self-learning tool, or whatever we are creating as an application, an immersive application, is all about whenever you are ready, you can experience it. You can learn whenever you want and whatever time you choose, basically. Then you actually ready to absorb that all that learning through immersive mediums. So it's always interesting for you. So that's what you want.
So that pretty much cleared my question. So the next question would be, what can be the use cases of AR VR in Industry 4.0 for aviation? So I guess the pilot example you gave
Yes.
in the last question would
That
be an
would be
answer
that.
to this question as well.
That would be for the training. That would be serving as an example. But apart from that, if you talk about air hostess, so there's a fear of seeing all those people at you, right? If you face a crowd, or if you face a stage fright, basically. So for VR, you can actually give that presence as well, that mental preparation as well. That is, if everybody is looking at you, since a steward or air hostess would be actually looking at a lot of people, looking at them directly, so you can have that experience, and that can actually prepare your mindset for it. So that is one way. You're speaking to a lot of people, and they can actually talk in different languages as well. So even that preparation, that mental preparation, can be provided through AR/VR mediums.
So I've been willing to ask this question, but I didn't want to interrupt you.
Okay.
So when we talk about the training of an air hostess and the pilot training.
Yes.
So there's a difference between a bunch of people standing in front of you virtually and people standing in front of you actually.
Right.
So I get the point. The practice is more efficient when it comes to air hostess training, but when it comes to the pilot training, don't you think it's not that effective and not that efficient? Because
I think
at
seeing
the
the
actual
real
yeah
people, real
yeah
people.
the actual cockpit is, you can experience how the actual cockpit looks,
Right.
but training on the cockpit virtually is a very, a difficult task. You won't be able to be that
I mean,
effective.
that comparison between the actual physical object that you can touch
Yeah.
and the virtual thing which you can face through because
Yeah.
they are digital basically. Uh, right. So that was the question.
Yeah.
So basically, when we talk about physical objects and then digital objects or virtual or 3D models, basically. So yes, indeed, when you are comparing physical with digital, physical is totally different thing. But if we talk about you being in an immersive system, you're wearing a VR headset, and then you are seeing this training module. This would be a totally different thing because what you're looking at a video, if you're looking at a real cockpit image or a video, that would be a 2D image. That would be a 2D video. But when you're inside a virtual reality, you're actually looking at a virtual cockpit. So you are sitting inside it. That will be a 3D layout of the buttons. All those panels that you have, they will be in 3D. So it will be a total different feeling for you because you would not actually like to go through that 3D model because you know that in real world this is the actual solid object. So your mindset will not actually allow you to actually go through the 3D models. But yes, if you try to put your hand on the cockpit, it will go through it because again it's a fake thing, it's a virtual thing. But even then, we actually program for the 3D model, your hand model as well. It will not go past through the geometry, but your real hand can. But whatever you see in the VR, your hand, your 3D model of the hand will stick on the surface, but your actual hand can go through. So when you, in the entirety, 75% of what you are actually experiencing now is through your vision only. So if we try to compensate for everything through visually, so by actually stopping your virtual hand on the surface of the cockpit, will actually make you realize that okay, my hand might not have gone through the this panel, but in reality your hand has gone through the 3D model. But your virtual hand that's on the that's actually showcasing your hand presence in the VR, it will be stopped over there. So
Okay.
you will actually feel like going over there. But then you're talking about 3D models, as in people standing in front of you in VR. That will never be that will never replace a real person, right? But even then, you have those nuances like somebody blinking their eyes, somebody like breathing, like somebody breathing. That 3D model is animated or in a way that is breathing. Even that's possible. That will not fool you into immersive systems, but it will still give you the idea that you are in a space where there are people who are looking at you. They are doing all those activities which people would actually do regardless, like looking at their phones, looking about ideally, or actually making eye contact and then looking away. So that's even possible in the because you're actually having all those animated behaviors that are actually being done randomly in front of you. So you might think that these are real people in a way because since you're giving somebody a learning that you are doing that buckling thing that the air
The
hostess do.
seatbelt one.
Yes, that thing. They have to do all that activity in VR while those people are actually behaving in a certain manner. So air hostesses are basically trained not to make any eye contact when they actually do demonstrating that thing. So they can actually learn that thing because that will be a white noise for them initially. Uh, they're actually being trained to actually uh, prepare themselves mentally to actually be in this kind of situation.
Interesting. So has Yeppar done something in terms of aviation industry? Have they created or they have created any kind of solution or any kind of training module when it came to aviation or the pilot training or the air hostess training?
Indeed, we have. So we have been lucky to actually create the entire airport maintenance thing, like how do you actually reroute a plane on the ground, and how do you actually do the parking for the plane. So we also have instructions for how to do maintenance for different AC compartments for the plane and everything. So we have been doing that thing, but that would be in VR. That is, you have the entire view of the airport. You can go to different locations of the airport. You can actually do the troubleshooting. You can have the maintenance aspect as well. So all those modules, and they load up whenever on demand basically. So we have been doing that thing basically.
With that being said, I'll move on to my next question. How does AR and VR enhance design process? So, like we were talking about the machinery, we were talking about the virtual walkthroughs of a plant.
Right.
So, how does AR VR help in designing all of that?
Right. So I'll take that to the manufacturing part again. So when we were actually trying to design for accuracy for perfection, that took us to the simulation area, right? We were actually simulating some kind of features, physical features, so that the product comes out pretty luxurious, efficient, and also pleasing to the eye. So that comes into play when you actually create those things and visualize in a proper manner. Since whatever monitor you are looking at, whatever your phone screens, they're 2D in nature basically. Since they're 2D in nature, you can actually expect to actually have a depth understanding of that thing that you're looking at. But when you're talking about AR and VR, these are basically immersive systems, and they have that 3D aspect to them. So when you wear HoloLens, or if you are wearing a virtual headset like Oculus, so whenever if you are looking at a table in front of you or furniture in front of you, it will be 3D in nature. So you will feel a depth to it. So you can actually get a better sense of it. It's spatially and then 3D space, and you can also see if the colors are appropriate to the environment or not. So having that insight, that how that thing is appearing with depth, gives you better understanding of it with the 3D space, and as in its entire form factor basically. So that helps you to actually design better. So simulation is one place where you're actually creating a better product through better materials, better usability, better everything. But AR, VR are good mediums, good technological mediums to actually showcase that particular thing in the in the best manner basically. Best immersive manner. There's nothing more immersive than VR basically.
Okay, so basically, it avoids wastage as well, wastage of time and.
By deciding
Mhm.
quicker basically, a faster decision.
Exactly, we
basically.
can just rotate and just see the 3D model, and
Right, right.
we can just zoom in, zoom out, rotate it, and see every aspect of it, and which will lead to a better design.
Better choices, better,
Mhm.
quicker decisions, faster decisions basically.
So
You can
instead of making
compare.
the entire thing and just thinking, this won't work, we should change this.
Right.
So it's better we created it AR or VR, and
And
then.
see to it and compare it basically.
Mhm.
So having that superpower to actually analyze better in front of you. So if you have a giant tractor placed over here, just by clicking your fingers, you can actually switch between 15 of them in this small space. So you can utilize one space for multiple machineries. You can reiterate through all of those things. So that way you can actually decide faster.
Okay. My next question would be how Industry 4.0 is transfiguring the pharma industry.
Right. So earlier we were talking about raw materials. So over here as well, we can talk about raw materials as in through these technologies we can actually calculate and actually forecast when actually we need certain raw materials to create a product. Product as in medicines. So in pharma, we actually want to effectively and quickly create the batches of medicines whichever there is a demand for. So in these scenarios, we can actually calculate when do we require the raw materials and what is the right quantity for the materials. So that is something that we can actually work for in the pharma. So that kind of insight and that kind of readily available raw materials. So that's through this kind of preparedness that comes with the Industry 4.0 technologies.
When it comes to pharma, is there only the raw materials and the preparation part we can use AR VR into, and or can we use it for a training purpose as well?
For AR and VR, obviously the immersive systems are very good teaching tools that is telling you how to do the maintenance part. So we as Yeppar have been working for pharma. We have a lot of use cases for pharma, and in pharma we have been giving the training aspect mostly. That is, you actually can do the dismantling, and you can learn about the assembly features for the particular machinery. And doing that, you can actually train people to be readily available for the particular troubleshooting or maintenance.
So moving on to my last question,
Yes.
what are the risks of an Industry 4.0 solution?
Risk.
Yeah.
Risk as in this would be a long shot in a way, but cybersecurity is one thing which can be a threat. That is, since you have this much data that's accumulated, that's a readily available cake, right? So if anybody wants to take a slice, they would be hacking the system, they'll be attacking the system. So one has to be well prepared for the cyber attack as well. So cybersecurity is one issue where this can go wrong. So
Can we also name it as a risk, loss of data or corrupting of files?
yes, earlier we did ask about, we talk about the hazards. So hazards is also one thing that you can actually lose a chunk of that data or that server, the terminal that's controlling the data that's accumulated. So yeah, so hazard is one thing. But even for that, the Industry 4.0 use cases, they actually compensate for the this kind of prevention for the hazards as well.
With that being said, here we come to an end to this webinar. If you have any questions, you can mention below and we'll try to enclose them in our next webinar. Thank you. Thank you, Shashank.
Pleasure.